Basha, can you see my screen now? Can you see
Yeah,
Python for data science
yeah,
visible?
yeah, yeah. The screen is clearly
All right,
visible, and
great.
also audio is also very clear.
All right, that's great.
Yeah.
So thanks, Ritesh, for responding as well. All right, so what we are going to do is, as Basha said, we are going to wait for a few more minutes. We are going to wait for a few more participants, and then we are going to start very shortly. Till then, I'm keeping myself on mute, but I'm happy to interact with anyone on the chat box throughout the webinar, so you don't have to wait till the end of the webinar. In fact, even before we start. So for the current attendees who are there, if you have any questions, please feel free to type it out on the chat box and I would be happy to reply to you. And let's wait for a couple of minutes and then we will start very shortly. What we're going to do today is we are going to talk about data science and we are going to specifically talk about data science using Python. So that's the agenda that we have for today. And just a second, let me just set my slide on presentation mode. Okay, so I want this webinar to be fairly interactive. So wherever you have sort of any kind of doubts, please feel free to type it on the chat box, whether it's related to what we are doing or whether it's generally anything to do related to Python or data science. Let's keep this interactive. Please feel free to type it out on the chat box anytime you feel. Okay, so a brief intro about me. I have close to 10 years of experience. My name is Apurva Vishnoi, and I have done my master's from Delhi University, and then I have done my MBA from Indian School of Business, Hyderabad. So I have overall 10 years of experience and more than 8 years of experience while training in Python, data science, machine learning, deep learning, and several other related sort of topics. I've been very fortunate to work on some very exciting projects like predicting what will be the wind speed tomorrow, and based on that wind speed, what will be the generation that you can get from wind and solar power plants. So another interesting thing that I do is I actually have developed stock market trading strategies using Python and data science. So that's another something very exciting, and that let's say if you happen to have an interest in the field of data science and Python, then this is something very exciting that you can actually directly use Python to make money by trading in stocks by developing some quantitative strategies. I've also been fortunate enough to do a lot of trainings for very reputed organizations in India, Malaysia, and even South Africa, and I'm associated with several online platforms as well. So I also have a lot of certifications related to this particular field on data science, on deep learning, and so on. All right, so that's a short profile for me. And now what we're going to do is we are going to jump into the topic. We are going to jump into the topic of data science, right? So data science has been in news of late and quite sort of quite often, right? So many a times we hear things about data science, we hear things about machine learning, deep learning, and so on. And let's analyze what is data science, right? So why data science has been so popular of late? Why is it that it's in news all the time? So if we Google data science, then what we find out is we find out these three links. These are three prominent websites which tell us what is data science. Now, there's a little bit difference in each of these three definitions, which we get from these three sources, Wikipedia, Investopedia, and Data Jobs. But there are few words which I've highlighted in similar color, which are common in all the three definitions. All the three definitions talk about the multidisciplinary part, right? That data science combines multiple disciplines, right? So people could be from different domains, people could be using different technologies, people could be using different tools, so that everything comes into the purview of multidisciplinary. Another thing which is highlighted in all the definitions in orange is the complexity of the data, right? We talk about big data, large amount of data. we talked about that data could be structured or unstructured. So structured data is a data which is sort of nicely labeled in an Excel sheet kind of format, which has some meaningful column names, some meaningful row names. And when we talk about unstructured data, we talk about data which is presented to us in a form like images, right? Or maybe an audio file or a video file. That is the kind of data we call as an unstructured data. So data science combines a lot of disciplines and help us solve complex problems related to data. And how do we do that? We do that with the help of technology, with the help of algorithms, and also with the help of the rapid computational power which is available to us at this age and time. Right? So data science is an amalgamation of the three aspects that we were talking about: technology, the complexity of the data part, and also it's a multidisciplinary approach which can be applied to a lot of different domains, a lot of different industries. Now, we said that data science is not something which is recent. It is not something which is very old. It is a very recent development. In fact, the term data scientist was not even there before 2008. It's that recent a term, right? But what has happened of late is that there has been a rampant demand for data scientists or similar kind of roles like data analysts and data engineers in a lot of companies. There has been a rapid increase in terms of demand of jobs. And in fact, it is called as sort of the most in demand sort of job through several surveys. Several people or several surveys from Harvard, several surveys from Glassdoor has ranked data scientist as one of a very sort of lucrative roles, a role which a lot of people are seeking out for, right? And a lot of companies are hiring for data scientists and similar kind of positions. Now let's understand why this growth has happened so rapidly, right? What is the main reason that this growth has happened so rapidly, and why is it expected to grow even further? So right now we are in 2019, or let's call it 2020, and we see that we are still in the beginning phase of sort of an exponential curve in terms of demand, right? So the main reason is that of late data has increased quite a lot, right? The term is data scientist. Data scientists work on data. What has happened of late is the amount of data which is present in the world has increased significantly. Why has that happened? Look at your social medias, look at Facebook, look at Instagrams. How many pictures are uploaded on these platforms every day? Or you can think about YouTube, right? So many videos are uploaded on YouTube each minute. You can talk about your e-commerce platforms, which have data for so many products and also so many customers, right? So massive amount of data. Think about your movie streaming platforms, Netflix, Amazon Prime. So in this world of social media, the amount of data that we are generating is really, really massive. That's one of the reasons why the demand for data scientists is increasing exponentially. But there's one more reason why this is happening. And that reason is that, yes, we have massive amount of data, but how do we sort of work on this data? How do we develop models on this massive amount of data? The answer lies in computational power. So even earlier, let's say maybe early 2000s, we still had decent amount of data, not as much as we have today, but still decent amount of data. But the computational power of our systems, of our personal computers or even supercomputers was not very high, right? So if you remember, the first laptop that you might have bought would be a laptop with a very small RAM. I remember that the first laptop that I bought had a RAM of 512 MB. So we are talking about megabytes over there. So the RAM was 512 megabytes, and that laptop cost me around 50,000 rupees, right? So 512 MB, and that cost me around 50,000 rupees. Last year, I purchased a new laptop. The RAM was 24 GB, right? So the earlier one was MB, not even 1 GB, and this one was 24 GB, and the cost did not increase that much. This laptop that I purchased was only for 80,000 rupees. So there was a several times increment in terms of the computational or the RAM power, but the increment in cost was not even twice the cost of the earlier model. And there were various other specifications like i7 and so on. So this is a development which has happened alongside the increment in data. The computational power has expanded, not only expanded, it is becoming cheaper by the day, right? Earlier, a laptop with an SSD was very expensive, solid state drive, but now it has become sort of significantly cheaper. So the technology part is improving rapidly along with the data, and that is why with the conjunction of these two things, data scientists or data analysts have become a very, this role has become a very hot role in terms of the job market. So let's review a few sources of data that are widely used all across the industries. We have talked about social media, then we talk about images, videos, audios, but there are other sources of data apart from these popular sources. For example, sensors, right? Some of you might be working in IoT applications, and you know that nowadays we are rapidly putting up sensors in several different applications that we did not think about were possible to monitor earlier, but that has been made easier with IoT, right? So there's a lot of sensor data which is also collected. Think about your GPS coordinates, right? So there's a lot of location specific data which is also being collected nowadays. We are also working on a lot of text data, right? So all the newspapers have become digital, all the magazines are becoming digital. So there's a massive amount of text data available as well. So it's not just the obvious ones like your images and your YouTubes and your Facebooks. A lot of regular companies, a lot of companies which are not massive social media brands or not massive e-commerce companies, even regular companies are generating a lot of data through sensors, through texts, through locations, and so on, right? So let me just hold there for a while and sort of open it to everyone. Any questions so far with whatever we have discussed? We are just sort of discussing the basics of data science, but please feel free to type out if you have any questions or any uh, answers you want in terms of applications or data science. Please feel free to write down at any point of time, uh, and that should be totally fine. Okay, so let's move forward. Now we know that there's a massive amount of data, there are multiple sources of data, and we also know that computational power has increased. But then what do we do with this data? What is the typical role of data scientist? How is it that a data scientist use this data to our benefit? So we sort of pose questions to the data. Let's say if we are suffering from a kind of problem, let's say we are Tesla and we want to develop a self-driven car, right? So if we want to develop a self-driven car, that becomes our problem statement. The next thing that we need to do is we need to collect relevant data so that our car can learn to drive itself. We need to collect a lot of relevant data. That data could be in the form of images taken from the dashboard of several cars, right? Now those images can tell us what is coming in front us, right? Or whether in an image do we see a red traffic light or do we see a green traffic light. So we would need to collect a relevant data concerning the problem we have at hand. After we have collected this data, oftentimes it happens is that there are certain anomalies or problems in the data. Some values are missing, some values are wrongly calculated, sometimes there are sort of errors in terms of calibration of instruments, or the instruments just stop working. So there are several kind of real life issues or real life problems that we face in data. So the second process is to do data wrangling or to clean the data that we have, right? To make it sort of make it proper, make it error free, and so on. After we do that, we sort of visualized the data to find out some trends from the data, right? What are the different elements which are there in the data? How can we summarize the data in through nice plots and get better intuition about what is happening with the data, right? Once we have done that, then we use some very advanced tools Some of you might have heard of pivot tables. Some of you might have heard of group buys, and then there are several other tools which are available in Python and other languages that we use to analyze the data for various different things, for the distributions, for the anomalies, and so on, right? For the trends. Now, after we have analyzed the data, now we can take one or the two routes. One of the option is to not do anything further with the data, but whatever we have found out so far through data visualization and through data analysis, we just report those results and present it to, let's say, our client, or let's say our colleagues, our superiors, and so on. And that is sort of analyzing the data in a retrospect manner, that we are analyzing the past data. We are sort of showcasing what happened in the past. Or the other approach is we can use this data to do or to train our machine learning models in such a way that they can learn from the data on their own and then give out predictions to us. For example, let's say we feed weather data to our machine learning models and we ask them to make a prediction on what the temperature is going to be tomorrow. Is it going to be hot? Is it going to be cold? Is it going to be cloudy? Is it going to be sunny? And so on. Or we feed data to our machine learning model about different customers, right? And we get predictions from our machine learning models on which of these customers is most likely to buy a particular product next from us, right? So there are these several kind of applications which we can use, for which we can use machine learning to generate predictions for future. So that is a typical role of a data scientist. A data scientist carries out all this work. Now, in sort of very large companies, even these roles are segregated a little. So there's a separate team which would do data acquisition and data wrangling. Many times we call them as sort of data engineers. And again, where a lot of sort of work is involved in data acquisition and data handling, then we call them data engineers. But if a lot of work is involved in data wrangling, cleaning the data and visualizing the data, then many a times we call them as data analysts. And then people who largely do a lot of data analysis and machine learning, they are sort of called as data scientists. And then there you could be a senior data scientist, you could be a principal data scientist, and so on. So there are several sort of different job roles that these particular aspects can be divided into as well. All right, so we have talked about what a data scientist's role is. Let's move on to some applications of data science, right, or machine learning models. What are some of the real life case studies through which we can benefit from machine learning? So machine learning and data science are used across the industries. So when we talk about marketing, operations, finance, even human resources, there are applications, very good applications for machine learning in all those domains, right, of business. Now, let's say if we talk about marketing. Now, online marketing or online advertisement is a big thing nowadays. Online marketing. So when I say a host, that means we are a company like Google or Facebook who sort of invites people to put ads on their website, right? So based on a host, we can use a lot of data, create a fancy machine learning model to get an idea about what should we price our ad at, right? What should be the right price for the ad so that we can make maximum amount of ad revenue. On the flip side, if we are a consumer of ad, let's say we are a small startup and we want to put ads online, to find out on which websites should we put the ads, right? And where is it that we put the ad so that we spend the least and we get the maximum sort of benefit out of that ad in terms of some customers clicking on that ad. Again, we can use machine learning to solve that problem as well. In marketing, there's a thing called customer segmentation, that we want to divide our customers into sort of different zones or different groups so that we can address them accordingly. Maybe certain people like to buy a small sachet of a shampoo, and maybe there's certain other set of people who like to buy the biggest bottle of the shampoo. right? So there are different consumers for different kind of products. Maybe there are some people who like to have a broadband speed of around 10 Mbps. And then there are certain people or certain customers who like to have a speed of around 50 Mbps, 100 Mbps, and so on. So again, machine learning is very useful in segregating which customer belongs to which kind of category. Now, particularly in the sort of domain of e-commerce, operations department is using machine learning quite a lot. Now, think about companies like Amazon who have to deliver millions of packages every day, or Flipkart, or even your food delivery companies like Swiggy and Zomato. There are a lot of optimizations problems that these guys have to face, right? Which delivery agent should we assign a particular food order to? Who would be the one who would be who would take collect the order and deliver the order in the fastest possible time, right? Because for companies like Swiggy and Zomato, customer experience is the main thing. How is the customer experience improved if they get the food hot and very quickly? So there are a lot of problems in operations, again, which can be optimized using data science and machine learning. Similarly, if we talk about the finance domain, then there are again several options over there. We can sort of use machine learning tactics or machine learning data or data science to get information about different customers, right? What is their age? How many loans have they taken, right? What is their salary, and so on. We could collect a lot of information over there and sort of predict whether the bank, as a financial institute, we should give out a loan to a particular person or not. Because if we give out loan to people who sort of have a habit of bouncing on loan or not making the payments, then it's a big loss for the bank. Think about Vijay Mallya, think about your Nirav Modi. There are people who have sort of fled the country and they have defaulted on the loans over there, right? So as a bank, it's a big loss for them, because if they have given a loan to someone, the way the banks make money is that the people repay the money with an interest rate. But if people sort of go absconding and do not pay the loan back, then it's a loss for the bank. So they want to only give loans to people who have the potential to give back the money. So again, machine learning models can be used to sort of go through the data and select the right kind of candidate to give out the loan to. Similarly, fraud detection as well. There are a lot of transactions which are happening online. There are a lot of transactions which are being sort of occurring on ATMs. All of them get recorded in terms of logs, right? So we could sort of scrutinize these logs to identify potential sort of thefts, potential sort of virus transactions, and so on. So again, finance has a lot of benefit of machine learning as well. And although human resources at the face of it does not appear to be an industry which would benefit a lot from machine learning, but surprisingly, it benefits quite a lot. Nowadays, there are thousands and thousands of sort of job applications given for a single job, right? So it's not possible for any HR to sort of screen through 1,000 resumes. But again, machine learning to the rescue. What machine learning models can do is read through those 1,000 resumes, find the right resumes which would fit the right kind of job, and sort of maybe filter those 1,000 resumes to the top 10 resumes, right? And then the HR personnel can personally evaluate those 10 resumes and find out the candidate to interview, and so on. So across the different industries, we see a lot of applications for data science. Now, it is not sort of restricted to typical businesses. It is also sort of widespread in terms of industries, say a medical industry, right? So doctors can also use machine learning quite a lot in evaluating x-rays, in evaluating whether the person has cancer or not. So there are a lot of applications that earlier we did not think machine learning could solve a lot of problems, but even the fields that we did not anticipate machine learning to be helpful at, they are being benefited by machine learning and data science tremendously. All right, so let's talk about a few more attractive applications. So we have talked about some few serious application in a way. Let's talk about some fancy applications about machine learning, which sort of most of us would be familiar with now. We have heard about in the news about self-driven cars. They are being sort of made by employing machine learning heavily. When we buy something on Amazon, we get a lot of recommendations from them that if you have bought this, you might also like this. So that again comes from machine learning. What they do is they see what are the kind of products which are similar to the products that we are buying, and they give recommendations based on that. We would have also seen automated chatbots. So if you go on a website, a chatbot is there to interact with us, and that's an automatic sort of chatbot. There's no person sitting behind over there, and the sort of algorithm is chatting with us and giving us useful feedback. When we talk about sort of security, facial recognition is a big thing nowadays. Earlier, there were a lot of companies which were using thumb imprint to, let's say, allow a person in the company or not. But nowadays, they have made it even more simpler. Now there are facial recognitions which are being installed at several sort of high profile industries, and I'm pretty sure with time it will also happen with regular companies as well, that they might start use facial recognition system to allow a particular person in the company or not. And there could be several applications, maybe at sort of the visa centers or passport office and so on. So there are several security applications of facial recognition. We are very well familiar with OK Google, Alexa, Cortana, Siri, and there are so many sort of speech recognition and voice assistant systems which are available. All of them are sort of built on machine learning platforms. And we have seen on Facebook from a long time that Facebook gives us suggestions by looking at our photos on who that person could be. Again, that's machine learning at work. We are trying to identify features of a person and trying to find out who that person is. So again, a fancy application of machine learning over there. So we have talked about a lot of applications of machine learning. Let's talk about a few tools which can be sort of used to help us in machine learning and data science problems, right? So a few popular tools which are available uh, are Python, R, and SAS, and there are several other tools also available. Some of them are complementary; they can work well along with Python, and some of them are competitors as well. But these three happen to stand out: SAS, R, and Python. So let's do a quick comparison between SAS, R, and Python. Right? Between R and Python, the competition is not that much because both of them are free. So both these languages are completely free, whereas SAS is a paid tool, right? So SAS is an expensive tool, but R and Python are free languages. Anybody can just download them and start using them. Now, because SAS is a paid tool, the customer support is better at SAS compared to R and Python, right? So that sort of difference is there, that because SAS is a paid tool, they can afford customer support, but because R and Python are free tools, they cannot afford customer support. The main reason why Python has become so popular for machine learning and data science application is the ease of learning. Even people who have never coded in their life find it easy to code with Python. So the main purpose with which the founder of Python, Hugo, sort of developed the language, and this is not a new language, this is quite an old language. It was developed in 1991, right? And R was also developed around the same time. But the main goal of the founder of Python was to make this language so simple that anybody should be able to learn that language. And that is one of the main reasons why so many people have started using Python, for machine learning and data science. So now this is a sort of a pie chart of 2018. Now, if you remember earlier, we were talking about two kind of analysis. Either we can analyze the past data and just report it, or we can use that data to train machine learning models to make predictions. Now, in these two pie charts, the light green color is represented by Python, the dark green color is by R, and the blue color is being represented by SAS. So when we talk about analyzing past data set, then SAS is sort of still the majority user over there. So majority of the people prefer to use SAS for analyzing past data. But when we come to sort of developing data science models on machine learning and prediction models, then Python is a very clear winner. 70% of the people prefer to use Python over the other languages. SAS is hardly there, and 30% of the people sort of use R for machine learning tasks. And this graph is of 2018. If we talk about 2019, if I remember from on the survey, this 70% has sort of gone up to 77%, around 77, 78%, right? So the number of people who are using Python to solve these problems has increased tremendously over the last few years. Okay, so we have talked about Python, we have talked about its applications, we have talked about data science in general, the kind of fascinating applications that that can be solved using machine learning and data science. We have talked about some very interesting problems like self-driven cars. We have talked about problems like face tagging. We have talked about things like speech recognition, very fascinating things which can be used by machine learning tools. Also some regular things like resume screening, things like telling us which website should we post an online ad on, or who should be the delivery sort of personnel who should deliver our food orders. There are a lot of simple things as well as very complex things which are being solved by machine learning tools. So now with that in mind, let's talk about the course that we are creating at Exerta for you, right? So this is a data science course which would use Python. And so this course will be a 36 hours course. And so depending on the batch, it could be a weekend course or it could be a weekday course. Now, because many of our sort of attendees are working professionals, we keep a 2-hour class on weekdays and a 3-hour class on weekends, right? So these 36 hours are sort of spread across 6 modules that we are going to cover in the course. And across this course, we are going to use sort of the most relevant case studies which are being used in the industry nowadays. And your assignments will also be very relevant to what is happening in the industry. At the end of the course, after the sort of you have attended the course and given your assignments, there will be sort of one big project that you have to also that you will also be working on. And sort of these kind of things, your assignments or projects, are all the kind of things which you can sort of directly put in your resume as well, and they will sort of add a lot of value to your resume. So our next course is going to start on 4th of January. So timing is something that we would also like to get feedback from you. This course which is starting on 4th of Jan, that's a weekend course, but depending on your interest, as of now, we are keeping the timing as 7 a.m. to 10 a.m. But depending on the feedback, we might change it slightly if there are more attendees who want the sort of webinar to be at from 8 to 11 instead of 7 to 10. So minor changes are something that we would like to sort of make adjustments to depending on the attendees' preferences. Now, finally, a very important thing is who can take this course, right? So many a times I see that students sort of feel a lot of intimidation because of Python and coding and so many complex things that we talk about. But actually, in this particular course, we are going to start from the very, very scratch. So if you have no idea of coding, if you have never done coding, it's absolutely fine. Python, that's the main thing about Python. It's one of the easiest language to learn to code, right? So anybody who has very basic understanding of algebra and statistics would be the right candidate to take this course. And as we go on this course, we are sort of going to learn several things starting from the very scratch, starting from the very, very basic things. Lastly, this course is through an online mode. So kind of in the mode that we are talking today, it would be through a webinar mode. And the option would be there for you as well to sort of interact, ask questions through chat and through audio. So mostly what we do is most of the questions are taken through chat box, and then at the end we also open the mic so that people can actually talk and ask their question through voice as well. We do not allow voice questions in the middle in most cases, because then other sort of attendees get disturbed with that. But the main benefit of these online modes is the access to recordings. So many times what happens is that we have some urgent work, some urgent meeting, or we have to travel for office or for personal things, and we miss out on classes. So that is a thing which is which is taken care of in the online mode, because uh, you are going to get. Sorry, I think the presentation stopped sharing, but I think it should be back on track. Can I get a quick reply from someone? Can you see my screen back again?
Yeah, Paul, we can able to see your screen.
All right, thanks, Mehboob.
Yeah.
So, we were talking about the online mode, and the biggest benefit of the online mode is that everybody will get access to the recording. So, in case you, maybe due to circumstantial things, you miss out on a particular class, you would still be able to access the recording and get up to the speed on the course. So, that's one of the real advantages of our digital world, that you can get access to online sort of classes and online recordings over here as well. Okay, so after you complete this course, you would have a very good understanding of Python, of data science, and of machine learning, right? So this course will make you well equipped with these three things, and you're going to work on a lot of real life problems, real life case studies, which are going to be sort of adding a lot of value to your resume, to your experience, to your learning, and you are going to really sort of gain a lot of cutting edge knowledge, which is sort of very much in demand nowadays in the industry. All right. So we are nearing the end of my presentation. What I'm going to show you is the last slide, I think, is the kind of modules that we would have in this course. So we are going to start with the basics. The first three modules are going to cover the basics about Python, and we are going to focus on the applications of Python which relate more to data science problems, or data science topics. So we are going to focus heavily on that. So the first three topics are going to sort of set our foundation, make sure that we are up to speed with Python, we understand all the data science related tools in Python. After we do that, then we are going to talk about data analysis tools in module 4. There are some very famous data analysis tools called pandas and seaborn. We are going to use those particular tools. And finally, in the last two modules, we are going to talk about machine learning, and we are going to build our own machine learning models to solve some very interesting problems. All right, so that's the end of presentation from my side. Now, what we can do is, if you have any questions on any of the things that we have covered, then I would be happy to answer those through chat box, or if we have the provision to open the mic, then you can just ask me on the chat box, and then I'll try to unmute as well. So we can do it either ways. Okay, so I get a question about which libraries are we going to use? Are we going to use TensorFlow or scikit-learn? So in this particular course, we are going to use scikit-learn, and we are not going to use TensorFlow. TensorFlow is the library which is used for deep learning, and so that is something which could be used for advanced course. But the most popular library out there for machine learning is scikit-learn, and we are going to use it heavily in our particular course. Okay, so another question is, would you get a certificate after completing this course? Yes, absolutely. So on the successful completion of this course, you are going to get a certificate from Axelta. Absolutely. All right, I think that's it. So let me, in fact, have a last and final call. So if there's anyone who has a question, please feel free to ask. Else, we are going to wrap up the session. Hope you had a good time and you learned something interesting and you found this course interesting, hopefully.
Yeah, thanks, Apur. Thanks a lot for the
Thank you,
session.
Basha.
And thanks to all the participants.
Right.
Yeah, I hope we are
All
good.
right. So, yes, I think we can wrap up.
Yeah.
And yeah. All right.
Oh,
Thank you, Basha.
yeah. Thank you,
Thank you,
Apur.
everyone, for
Thank you.
attending.
Have a good weekend. Bye.
Thank you. Bye.